All right, so let's do some radian problems. So the big idea is that if we want to find, there's a formula for the arc length. So the formula goes that the arc length is equal to the angle times the radius. Now, the thing is, with the angle, this must be in radians. So if they give us degrees, we have to convert degrees into radians. And that factor, conversion factor, is the fact that pi and 180 degrees go together. Right? It's a ratio of pi over 180 or 180 over pi, depending on which way we want to go. But since we want to go to radians, if they give us radians, then we're good. We don't got to convert. But if they give us degrees, then we have to convert to radians. So let's see. The central angle measures 3 pi over 2 radians. So there is the angle. The radius is 12 centimeters. So what is the length of the intercepted arc? So that means what is the arc length in other words? So the arc length is going to be equal to 3 pi over 2 times 12 centimeters. Well, these are going to cancel, the 2 and the 12. 2 goes into 12 6 times. So then we multiply, right? Then there's just a 1 on the bottom, so I don't care about that. So multiplying straight across, 3 times 6 is 18 pi centimeters. D. Number 2, an arc of a circle with diameter 8 inches, right? So diameter, we're going to be able to get the radius, right? Radius is half the diameter. Has a length of 3 pi. So here's where it gets kind of, you got to really pay attention to what it's saying. It's saying that an arc has a length. So the arc has a length. So the arc length is 3 pi. So that means the thing that we're missing is the angle, right? Because we need to have this formula, right? There's 3 things: arc length, the angle, and the radius. We need two out of the 3. So the angle is the unknown. So this is going to be arc length, which is 3 pi, is equal to the angle. We don't know it, so we'll call it x. And then the radius is 4 times 4 inches, because half the diameter. So then solving for x, the angle, we got to divide both sides by 4. And we see that x, or simply the angle, is equal to 3 pi over 4. Number 3, as part of a birthday party, each guest will get to decorate one sector of a cookie cake, their own frosting. So it's going to look like this. The central angle of each sector measures 1 radian. So right there's my angle, 1 radian. And the radius of each sector is 6 inches. So 6 inches. So there's my radius. So the one thing that we're missing is arc length. If one guest frosts a piped line of icing completely along the outer edge of their cookie, how many inches of frosting will be used? Okay, so this length right here, how long is that? So let's see. This is going to be arc length is equal to the angle, 1 radian, times the radius, 6 inches. So 6 inches. It's almost ambiguous, right? Like it's saying if one guest frosts a piped line of icing completely along the outer edges of their cookie, how many inches of frosting will be used? So are they just frosting the red line, right? Because 6 inches would be 6 inches would be just that edge. But if they're frosting the outer edges of their cookie, so like this, then that'd be 6 times 3, which would be 18. So I guess it just depends on how you want to interpret this. So it's 6 inches if it's just along that one side, and then it's 18 inches if they use all 3 sides, which I feel like it's all 3 sides because it says outer edges, which implies more than one edge. Probably go with C on that one. All right, a slice is cut out of a circular pizza with diameter of 18 inches. So diameter is 18. So that implies that the radius is going to be 9. The arc length or curved edge of a pizza that was cut measures 6.5 inches. So there's the arc length. So arc length, 6.5 inches. What is the measure of the central angle that was used? Okay, so basically it's that sector piece, like that pizza slice. So this is going to be so here's my pizza slice. They said that the radius is 9 and that the arc length is 6.5 inches. So arc length is equal to the angle, which we're looking for, times the radius. So arc is going to be 6.5, angle unknown, radius is going to be 9. So then divide both sides by 9. 6.5 divided by 9. 0.7. So it doesn't necessarily have to have pi in the answer. Just know that. Okay, that was 4. Number 5. An arc of a circle with radius 12 has a length. So there's the arc. There's the arc length and the radius. So the arc length is 21 pi. The angle, unknown. Radius is 12. Divide both sides by 12. So 21 over 12. Both those are divisible by 3. So 7 pi over 4 matches D. Right, and just in case you missed it, This was the arc length. This was the angle. This was the radius. Right? And they're being multiplied. Angle's always in radians. That's why it says radians. Okay. Number 6. The length of arc, so the arc length AB is 67 inches. The radius is 3 inches. Determine the angle. All right, so this gets very repetitive, very quick. Divide both sides by 3. 67 divided by 3. 22.3 radians. Okay, this one looks fun. This one looks fun. All right, the radius is 5. So radius is 5 units. The angle RDQ has a positive measure, RDQ, okay, of 5/4 pi radians. So then there's my angle. That's exactly what the picture's showing here, okay? A string with endpoints E and R. So here's the string, and it can be wrapped around the circumference of the circle D. So basically, those dotted lines are implying that it's a string, and if we lay it down, it'll eventually, basically, E would match up with Q, basically, is what would happen. E would match up with Q. So arc length is what we're looking for. That's what I'm getting at here. The arc length. So the arc length is equal to the angle 5 pi/4 times the radius, which is 5. So this would be 25 pi/4. That's how long we would need it. Is that one of our answers? It surely is. C. 25 pi/4. Okay. In a given circle, the length of an arc, so arc length, intercepted by a central angle, so of x radians. So the angles are the unknown. We don't know what the angle is. And 14 is the arc length. So kind of reading this, you got to be very careful. So in a given circle, the length of an arc intercepted by a central angle of x radians is 14 centimeters. So the central angle is x radians. The length of the arc is 14 centimeters. And the radius is 3.5. So arc 14, angle unknown, or x rather, and then the radius 3.5. So we put it all together. 14 is equal to x times 3.5. Divide both sides by 3.5. We get B, 4. And it's in radians already. Which of the following describes the radian measure of an angle? So which one is the formula that we've been using? We've been using arc length is equal to the angle times radius. Okay, here the angle, another symbol for angle, is the Greek letter theta, right? In algebra, we use x to denote numbers or an unknown variable. In geometry, the Greek letter theta is the Greek letter that is reserved for specifically an unknown angle. So solving for theta, we get divide both sides by the radius. So the angle is equal to arc length divided by the radius. Angle is equal to arc length divided by the radius, which is A. Theta is equal to the arc length divided by the radius. All right, last question. A central angle measures 3 pi over 2 radians. So there's my angle. If the radius is 12, what is the arc? So 3 pi over 2 times 12. I feel like this was like the first problem. So this would be 6. 6 times 3 is 18 pi. There's no way. 10 and 2. Well, not 10 and 2. Central angle. 3 pi over 2 radians. Oh, that's interesting. 1 and 10 are the same. Haha. Okay. Well, hopefully this helps someone out.